For number 4, remember we have to first check to make sure we can multiply the matrices. So I got to check their dimensions. So the first matrix has 1 row and 3 columns. The second matrix has 3 rows and 3 columns. Middle numbers match. That means I can multiply them. My answer is going to be 1 by 3. So it's basically going to look like that first matrix. So it's going to be a flat, long matrix, 1 by 3. So basically just 3 numbers. Be a number there, there, and there, and that's it. So same process. For the first matrix, I only use rows. I'll start with row 1. There is only 1 row. For the second matrix, I only use columns. Okay, now these have 3 numbers. Not a big deal. First number times first number. So -2 times 3, -6. Plus 4 times 2, 8. Plus 1 times 0, 0. Add all of those together. That's going to give you 2. That's the first row, the first column. The first row, first column number is 2. Okay, now I hop to my next column. Oops, didn't want everybody to move there. So now it's going to be -2 times -2 plus 4 times 1 plus 1 times -1. So I've got 7. That is in the first row, second column. That space is in the first row, second column. Go to your next column. Again, go through all the columns, and then you'd hop down to the next row, even though this one only has 1 row. So -2 times 4, again, first number times first number, -8. 4 times 0, 1 times 4, I'd end up with -4. And it's done because there's no second row to hop down to. There's no other row here to hop down, so we're done. If there was a next row, we'd hop down to it, we'd cycle back, and repeat the process. For number 5, we want A times B and B times A. So again, I would suggest drawing them since they're not bumped against each other yet. So I got to check to see if I'm able to multiply them. Matrix A is a 2-row by 3 column. Matrix B is a 3-row by 2 column. Middle numbers match. So yes, I can multiply them. My answer here is going to be a 2 by 2. So this is going to actually crunch down to just 2 rows, 2 columns. Only rows on the first matrix, only columns on the second matrix. And usually when I was doing these matrix problems, there's a lot of numbers written off in the margins. That's the multiplying. So 1 times -2, 0 times 1, 3 times -1. Add those together, I'd have -5. So that was row 1, column 1. Hop over to the next column and do some multiplying. 1 times 4, 0 times 0, 3 times 1, add those together, 7. That was row 1, column 2. I've exhausted all the columns, so now I reset the columns and jump down to the next row. Two times negative 2. Let's see, negative 1 times 1. Negative 2 times negative 1. Add those together. Negative 3. Move columns. Two times 4. Negative 1 times 0. Negative 2 times 1. Add those together, 6. There's A times B. All right, now it wants B times A, which again does not necessarily mean it's going to be the same thing, and this one's not. And what's weird about this one, when I do B times A, it's not even the same size matrix for the answer. So B times A let's check their dimensions. Matrix B is, again, a 3 by 2. Matrix A is a 2 by 3. So again, the middle numbers match. So yes, I can. But now my answer is going to be a 3 by 3 matrix instead. So not only do I not get the same answer, I don't even get the same size matrix. Rows are the first one. Columns are the second one. Okay, I'm going to go a little faster now and not write out all the individual calculations, but I'll talk through them real quick. So negative 2 times 1, 4 times 2, add those together, 6. Move to the next column. Negative 2 times 0, 4 times negative 1. That would combine to be negative 4. Keep changing columns until you're out of columns to use. Negative 2 times 3, 4 times negative 2, so that'd be negative 6 and negative 8. That's negative 14. Okay, you've exhausted all the columns. Reset the columns back to the beginning. Hop down to the next row and repeat. So this would give me 1 times 1, 0 times 2, 1. Next column. 1 times 0, 0 times 0, 0. Next column. 1 times 3, 0 times negative 2. That would give me 3. I've exhausted all the columns, reset the columns, hop down to the final row. I'm not going to go through all these. I'm just going to say, okay, so you do row 3 times column 1, row 3 times column 2, row 3 times column 3. That will give you your last 3 numbers, which are 1, negative 1, and negative 5. On number 6, AB times BA, I'm sorry, A times B, so A times B. Okay, let's check if I can multiply them. The dimensions of A, it is 2 rows by 1 column. Matrix B is 1 row by 4 columns. Middle numbers match. My answer is going to be 2 by 4. So 2 rows, 4 columns. So it's going to be 2 rows, 1, 2 by 4 columns. 1, 2, 3, 4. This one's a little bit different because rows are the first one. Well, there's only just a single element for the row. Columns are the second one. There's only a single element here. So when I do row 1 times column 1, there's only one number in each to multiply. So there's no adding stuff together because there's only one. So 10 times 4, so 40. I'd hop over to column 2. 10 times -1, -10. 10 times 0, 0. 10 times 5, 50. Those are just going to be the other numbers. So again, 10 times -1, -10. 10 times 0, 0. 10 times 5, 50. Again, that would have ran me through all of the columns. So I would have reset, hop down to row 2, and repeat. So it's going to be -2 times 4, -8. -2 times -1. And just keep on rolling. So as I go through all those, here I would have had -8, -2 times -1. It's going to give me 2. -2 times 0, -2 times 5, -10. So there's AB. BA, I can't even do because B is a 1 by 4. A is a 2 by 1. The middle numbers do not match this time. So I can't even do it. So BA is not possible. So we've had some interesting things here. We've had where multiplying them both results forward and backwards results in the same size but different numbers. Then we had different size and different numbers. And now we have forward works, backwards doesn't even work. On number 7, let's check the dimensions. Well, I've got a 3 by 3 and a 3 by 3. Middle numbers match, check. My answer is going to be a 3 by 3. Now, I'm not going to do all the calculations on this one. I just want to show you, a little, or give you a little reminder. So I know I'm going to get a 3 by 3 matrix here. Let's say you get lost in the matrix, which is entirely possible. There's a lot of numbers flying around here. Let's say it's, I don't know, right here is the number you get lost on. If you're going, okay, wait, I'm not that number. What do I multiply by what? Well, just ask yourself, what row am I in? I am in row 2. Well, rows are always the first matrix. So row 2, what column am I in? I'm in column 3. So columns are always the second matrix. So I must be multiplying row 2 times column 3. So that element, that empty box there, would be 2 times 4, -1 times -1, 0 times -2. Add those together, that element must be 9. Let me show another one. Again, let's say you get lost and it's on this number right here. Well, just ask yourself, what row and what column am I in? I'm in row 3, column 1. So that must mean that I'm taking row 3's numbers, multiplying by column 1's numbers. So that one would be 4 times 0, negative 2 times 1, 3 times 3. Add those together. Must be 7 down there. So again, that's just a way to remember what it is you're actually doing. And that's what the actual definition of matrix multiplication was trying to say. It just says it in weird symbols. If you finish this one up, I'm going to give you the other numbers here so you can practice. Negative 15, negative 16, 3, negative 1, 0, and we already have the 9. 7, we already have 6, 12. So if you multiply those, that's what you're going to get for a final answer.